Hello, people. Thanks for coming to our talk. After really good keynotes, one of them was the creator of scikit-learn talking about democratizing the machine learning pipelines and how to make it easier to people do machine learning. And I think this is a pretty relevant theme in our current era. So we are going to talk how we try to, in the same essence, how to simplify and democratize the access to data between business users. And I'm André Midea. I'm an engineer at Nubank. I've been working at Nubank since, since it is almost its beginnings for 5 years. And I've been doing multiple roles as any good startup. So I did a lot of systems engineering, and now I'm focused on the data platform for the last 3 years.
And I'm Rodrigo. I'm also an engineer for Nubank. I have been working with technologies like Kafka, Spark, Redshift, Google BigQuery, and other technologies as well. So before we start, I want to talk a little bit a story about Nubank. Nubank is the biggest fintech, 100% fully digital bank outside Asia. We started as a credit card issuer in 2014. And in 2017, we start our own version of a bank account. We have other products like rewards and lending products as well, but these are the main ones. In 2019, we start international expansion. So we are in Brazil right now, but we're expanding to Mexico, Argentina, and we also have an engineering hub in Berlin. This is a picture of us in São Paulo 2 years ago. Now we have 2,000 employees. I don't think we can fit in a picture anymore. But yeah, that's a cool picture, right? And this is a graph showing our growth over time. So in June of 2014, we just had friends and family. And now in June of 2019, we achieved 12 million customers. And to be honest, this graph is outdated. In the last 3 months, we already grew 3 other million customers. So we have 15 million customers using our credit card. And since the company was growing really fast, we started to create different roles that can use data, right? Like they need data to do their daily jobs. So we have business analysts, financial analysts, the legal team, data science, and customer support. And what's clear for us, we are a startup, right? So at the beginning, we didn't have a data platform. And it was clear for us that we need to build a good data platform to achieve this growth. Cool.
So while we were thinking on how to create a data platform, we didn't start Nubank creating a data platform. We started since the beginning with a microservices architecture, so we knew how that things would, we would have to scale. And as someone that did microservices architecture knows, ETL is something that you eventually need. But we started creating some solutions, and then we achieved the point that, okay, we need to create some kind of solution for the end user. And because people were, I need this data, I need to create this report, I need to send this to the central bank, I need to do this and that, and a lot of people creating machine learning, because we were a small startup offering credits in Brazil, so we had to have a really good credit models and credit policies, and so we had to deal, we had to have a really good data science team, and they need data. So while we were building and facing, and from previous experiences, we kind of saw this pattern of the report lifecycle. And this pattern is kind of like this. You have your business user, full of ideas, has, I don't know, a data science. I have this idea. Maybe this is going to get us millions. And then the data science doesn't have the data, doesn't have the skills, or it's super complicated to do the process. So it goes to meetings, it goes to the engineering team, try to add this requirement, this report, ask them to create this report and add that to their backlogs to prioritize and so on. Afterwards, the engineer eventually goes and, okay, let me implement this, and then you know what happens, right? No. It's not, it gets back to the business user, and the business user says, no, it's not exactly what I want. I want a little bit different. And then it goes back. So it goes back to the meeting and then explain it to the engineering. So we have this conflict of interests that I think is pretty common. Have you ever faced something like that? Can you raise your hand if you've seen? Yeah, it's pretty common, right? So I think that's something we try to avoid as much as possible. And because there's really no other way. If you have like conflict of interests, that's going to happen. There's two options. Or you keep in the cycle and you, okay, comply to it, or you just leave the company to, I don't know, a more flexible place. So it's frustrating. It's frustrating for the business users because they think the engineers are super slow, they don't implement the things correctly. It's super painful to start and to have a new idea, so they just start like having the decision based on decisions on biases and so on without backing their decisions with data. And also the engineers, they think about the business users. Oh, those guys underestimate the challenges of implementing something production ready, and they want to do like every other week, they want something new, something different, and they want to change everything, the requirements. So it's super frustrating for everyone. So when we were deciding to build a data platform, we decided to build something that has the incentives aligned. So people should be, the end users, the business user should be empowered to use data to create creative solutions, they're empowered to create some nice things with data and in a simple way. So I think it's really important, this word, like the incentives are aligned, because they want to use the data to make better decisions, so they should be able to do so. And we are a Clojure company, so we do like we have 300 plus engineers doing Clojure, and every Clojure talk, you have a definition from the dictionary. So ours is democracy. What is democracy in this sense? So it's the absence of hereditary or arbitrary class distinctions or privileges. So in our context, it means that everyone that wants to use data, they can use, and there's no distinction. Even though I'm not like a super technical user that knows Spark, knows data pipelines and so on, I'm still able to use the tooling that we have and the data that we have available at Nubank to make better decisions. And that's a pretty common movement in the software industry. We've seen that in the Agile movement, where instead of having like conflicts between customers and the team, where the customer wants to like add as much things as possible to his scope before you close the deal, because then they couldn't change, and the engineers like, I'm not going to change this because it's like too late in the process. So Agile was all about bringing the customer closer with shorter iterations, not being afraid of making changes. DevOps is the same thing, like the same theme, like sysadmins and engineers, one keeping the service running and the other trying to make changes. So so the sysadmin, they didn't like to change the things that are already working, and the engineers, they didn't care that much about performance, how the software would perform, because it wasn't their responsibility to keep the service running. So I think, and DataOps is something new, and which has this point where reducing heroism, which you don't have like a hero that knows about the data, where the data lives, and is able to create the reports. So I think it's based on that we were creating our platform to align the incentives. And we're going to talk a little bit about the principles that we use to achieve that. Yeah,
as Midaya said before, we cannot just go there and create a data pipeline without thinking about principles first. If you want to democratize data and have everyone in the company using data, we need to think before building everything, right? So before talking about the principles itself, I'm going to talk about our technology stack. At Nubank, we use a programming language called Clojure, and we are probably the biggest company using Clojure in Latin America today. Clojure, it's a functional language, runs on top of JVM, and it's based on Lisp. We love functional programming, so everything that we do, we try to apply the principles of functional programming, like immutability, for example. We also use a database called Datomic. The Datomic database is one of the reasons of why we're using Clojure. It's not the only one, but it's a bigger one, the bigger one. Datomic, it's accumulate only, which means immutability. We never change the past, we never raise data, we just append new data every time that we want to do a transaction or something like that. It's like a Git for your data. And the beautiful thing about Datomic is that the transaction log that Datomic can provide to us It's really powerful. We use that to create our ETL pipelines later. I will explain later. And of course, we use Apache Spark for processing this data. Apache Spark is really powerful because of the lazy transformation. It's declarative and is inspired in functional programming as well. It's important to say that about closure in Datomic, we have a pattern inside Nubank where every service that we build, it's using these two technologies. And we have a lot of really good principles that we are following as well. I'm not going to explain the other images in this slide, but we are also using Kubernetes, Google BigQuery, Databricks, a lot of AWS solutions, and Kafka. Some numbers about our engineering team. We have more than 330 engineers working right now, with more than 315 microservices. We estimate that we have 400 deploys per week, and more than 8 terabytes of data, customer data. I'm not talking about logs being generated by services here. And this data is shattered across 13 shards. Also, to run Datomic, we keep an infrastructure with more than 2,100 Datomic transactors. So just to explain a little bit with images now how our stack look like. This is a common stack in Datomic. We have a lot of services running Clojure, and they use a Datomic DB on top of DynamoDB. The communication between the services is dealt by Kafka. We have a Kafka cluster there. And we shard our infrastructure by customers. So imagine that we don't have just one big shard with all the customers inside. We actually break our 13 million customers in 13 different shards. So we replicate the same infrastructure in 13 times. And if a user is using our application, we just map the user to the right shard so you can apply the right transactions, for example. And more than that, now that we are expanding to other countries as well, we are also sharding by the country. So we have an AWS account just for Brazil, sharded by customer there, and we have a AWS account for Argentina and another one for Mexico. And it's important to say here that our data platform needs to know everything and get data from all these different places, different accounts as well. That's how we start our first principle. If you want to make sure that everyone is using your abstractions, you need to have all the data. So data coverage is really important. And when I say all the data, I really mean all the data. I don't want to get just a piece of the data and then have my business users trying to find another way to get the data later. I want them to follow the same patterns that everyone is following. So to do that, we actually get the transaction logs from Datomic. So for our 13 shards and our 300 services, we just scrap the logs every day. And save the logs in S3 has a Parquet format or an Avro format. Okay, but why do we scrap the logs every day? And I need to explain a little bit about how the logs looks like. Datomic works with EAVT. EAVT means entity, attribute, value, and transaction. There are other attributes here as well that I'm not going to go into details because I think it doesn't matter to explain what we are trying to explain here. So this is an example of a Datomic fact. I have an entity ID, in this case 28, an attribute, in this case name, and a value, in this case John. In a normal database, if I want to change something there, I would just erase the value there, in this case John, and like run an update or something like that, and write Lino in the place. But the problem is, you're losing data here. You don't know that the previous value was John, and what you can do is actually maybe create a column with the date saying, okay, this is the date where I changed that value, but this is not good enough because you need to go there and do this by yourself. Datomic gives this for free for you. So remember when I said that Datomic, it's immutable? It means that we never change data. We just append new data forever. And for a bank, this is awesome because we can know everything that was happening in time, like back in 2017, 2016, it doesn't matter. We just keep all the records that are happening at the database. So in this case, for example, if I check for the transaction 1 in this case, you can see that the operator was true, which means that the value John was the true value in that point in time. But for the second transaction, another point in time, maybe in the future, we change it. Now the value is not John anymore. The value is Leno. And we know that because we can have 2 facts for the same transaction. And we know that we moved from John to Leno in that transaction. And this is really important for us because we can actually get all the transaction log and replay the logs at any time and reconstruct everything that happened before. It's a really powerful tool for ETL. And we are using this actually to build our ETL, immutable version of an ETL as well. This is a closure code example of how we use the atomic log API to get the logs. So it's a really simple example, but as you can see, you are just like passing 2 points in time here and actually extracting data from this interval. And the result is just a collection of datums. Another problem that we face is that, okay, I can have the logs and I know what to do with the logs, but how can I find new services? If we have 300 services, 2,000 people work in the same company, how can I understand what is going on in the other part of the company? We don't need to, because everyone inside Nubank uses infrastructure, has a code to create new services. So if someone is creating something new, like a service for chargeback or a service for lending, for example, they don't need to tell us that they are creating this. They just define the services in a single place, a single repository. In this case, we have an EDN file explaining that someone created a service called Diablo that has the atomic database, Kafka enabled, and a lot of other properties as well. So we can just read the same repository and find out which services are appearing or not. They don't need to talk to us. And since we know the services, we know that we want to scrap the transaction log of what is going on in that database. How can we make sure that after getting these logs, the data frame that I'm going to be creating in Spark later will follow the same schema? Well, remember when I said that at Nubank we have a pattern that everyone follows? This is one of the patterns. When you are creating a service, you are actually defining a schema of what your database will look like. So in this case, the database will have a partition ID, a partition path, and a partition data set. And when you want to actually spin up a new service with this code, you need to pass some tests. And one of the tests is, if you're not updating the same version of the schema in the ETL, we don't have a contract here, so your service won't go to production. And this way we can make sure that we are speaking the same language when we are getting the data from one side and trying to load in another side. And more than that, people don't need to write this Scala code. They actually run a command line CLI that we have, and this is auto-generated for them. That leads us to our second principle. I already said that we need to get all the data, but at the same time, if you think about all the data and if you have conversation with business users from different places, you find out that some people have a problem, other people have other problem, and they don't agree in what is the best decision for the company. The second principle that we followed, it's no need to access a future. We want to create something that maybe are not going to be enabling everyone at the same time, but at least it's giving the right roads to follow. So if you follow our roads, you can actually create an abstraction later on top of what we're doing. But the idea is we want to create something generic and not stop by roadblocks created by other squads as well. So there is this quotation from Nathan Mars in the Big Data Principles, where a batch view, and you can translate this to a report maybe. A report is actually a function on top of all data. So if we got all the data that we have inside the bank in one single place, how can I make sure that we are enabling our users to actually get this data and do something with that? So if we want to apply a function on top of a data, we can try to find better ways to do this. This is how what I said right now looks like in Scala code. So a report, it's actually a function of a map of a string and data set. The string is the name of my source. And the data frame, it's the source itself. And the result, it's another data frame. And when I'm saying data frame, I'm talking about Spark data frames here. So what we want to do, it's actually apply functions on top of this data. So imagine this case where I have a dataset 1 and a dataset 2, and they are just sources. I got this from my microservices directly. And someone wants to create a report that is actually joining data from dataset 1 or dataset 2. What they need to do is just specify one little function that will join this data, for example. And we can actually extend this abstraction later. We can use a function on top of another function, for example. If you look to dataset 5, it's applying a function on top of the father node. And as you can see, this is a DAG of dependencies, right? One dataset depends on another. And this is pretty cool for, in some cases because we can define things here. So if I'm actually defining some specific term like churn, for example, some part of the companies could define churn as like leaving in 3 days, other like leaving in 5 days. But if you have just one single place where everyone is defining everything, I can define one node defining that churn, it's actually 5 days. And everyone can use this. Translating the DAG to Scala code. So since we are like drawing a DAG, the Scala code will look like a node, right? A node in a graph. And a node in a graph needs the inputs and the output. That's it. So you have the name of your data set. You have all the data sets that you depend on, and a definition function, the function that you are actually going to write something. The definition could be like a join or an aggregation or something like this. And for us, the definition will receive a map of everything that you defined in the input. So if you define input dataset 1 and 2, you're going to receive dataset 1 and 2 inside the definition function. This is an example, a real life example of one business analyst that was writing a dataset at Nubank. So he defined the name of the dataset. He said that the inputs are just one dataset in this case. There are all the calls that were being made to Nubank. And he defined the definition function. And if you see here the definition function, the only thing that he needs to do is use the DataFrame API. And the DataFrame API looks very similar to a normal SQL query. It's just like he's just filtering out all the calls that don't have the number, the expected number. In this case, 99999. And the business analyst did this in 30 minutes, just following a playbook. Okay, but you might say, yeah, but this abstraction is not good. No one will use this. It's hard. It's a Spark and Scala. But at the beginning, everyone was really afraid of writing Scala code, the business users. Yeah, I know. But we have more than 300 business users using these abstractions. Our playbooks are so good, and abstraction is so good that people don't need to understand about Spark, don't need to understand about how many machines or memory or clusters. They don't need this. They just go there and write a piece of function that will transform the data that they need. And we have more than 15 pull requests per day and almost 500K lines of code just creating data sets. And these are all business users, not engineers.
Cool. So that brings back to the principle 3, which is kind of keep it simple, stupid. So if you think about using data frames as the core, so data frames is already one abstraction. If you think about using data, like a list of data frames, which represents all the data and returning a data frame, that creates you a really solid abstraction that people can extend to do a lot of things. So even though we were only supporting kind of, you're declaring the inputs you need, you get this, you do some of the Spark operations, and you return this data frame, and it's kind of this black box that we are gonna take care, run for you, decide where to write, where to get the data from, so we are taking care of that. It's a simple abstraction, but it's kind of, that's why what we mean by pave the roads, because we are paving a simple, like we have this building block that you can create more specialized building blocks on top of that. So that's kind of worked pretty well. And for example, people were doing, without us knowing, people started doing like Spark ML on top of that same abstraction, because Spark, like, predicting things, basically you have your set of features, you apply some Spark ML pipeline, which receives a bunch of data frames and returns a data frame. So it's very extensible. So whenever we're thinking on adding a new abstraction to the platform, we always think on what is the kind of more basic building block that we can add that's going to have the impact and that's going to be extensible. But in this case, not keep it simple, it's keep it batch. So all of this whenever it's really, I don't know, it's really cool nowadays to do streaming, to do, I don't know, unbounded data sets, to do like Kafka Streams or Spark streaming and so on. But the streaming, it adds a lot of complexity to your processing. So it's not something that a business user is just going to declare its streaming pipeline and everything is going to work out, because it needs to understand what's the window, if it's going to have like late data arriving and so on. So we always try to, and we saw that batch, they take care, like most of the use cases, they work just fine with batches. And it's way easier to reason about. So one of the things that we always keep in mind is, let's use batch as much as possible, because it's way easier for engineering and for everyone to reason about things. And one of the things, like quoting Donald Knuth, it's premature optimization is the root of all evil. But the full quote is like 97% of the time, premature optimization is the root of all evil, yet we should not pass up our opportunities in that critical 3%. So when you're doing batch, and you kind of, as Ney explained, that we have all the sources of all data sets, they're kind of the transaction logs, so a known schema, we can apply some optimizations. So this is basically how people were talking about like like golden data, silver data. We kind of have similar definitions. So we have raw, which are the transaction logs. So it's platform maintained. No one uses that directly. It's append only. They just append only the transactional logs. And then you have contracts. Contracts is basically that definition that you get a skeleton, it generates a Scala class, and it's basically a contract between production and the analytical environments. And that's user generated. So the users contribute to that. And then you have data sets. Data sets is user contributed. So we have many data sets, and we don't exactly know what the data sets are doing. We just know that we need to run, and they're going to depend on contracts. So you can see that the platform maintains the things that we know for sure. So we can, whenever we are optimizing something, that's the part that we focus on. So optimizing the things that we know. So raw log, for example, from raw log to contracts, each database has its own transactional log. So, and we have one database per microservice, per shard, per country. So it's a lot of databases. If you want to know, for example, if an analyst would have to get data from all the different databases in different shards to get, I don't know, the count of customers that we have, that would be super hard. So what we do is basically create the contract layer that kind of simplifies that. It gets the definition that you added in our project, that is your kind of analytical schema, and we basically do the pivoting, and we create this kind of nice table for you to query that has the aggregation of all the transaction logs pivoted with the latest snapshots. And to leverage that, to make it really fast, for example, we apply a cache. As the transaction logs append only, immutable, in a point in time, we can just, okay, let's run only the delta for this case. Running the delta and like doing incremental data sets for the user data sets is really hard because it depends on a lot of variables. But in our case, we know for sure, because the transaction log, the inputs, they're all only append only, so you can kind of do the delta and apply. So that's by what I mean by like optimization. And another cool characteristic from batch that usually is not as, I don't know, people don't know that much and don't think about that much is the daily effects. So whenever, for example, if everything that we base or that the user creates, it's always based on this immutable log. So that's important. And for example, let's imagine that a user is creating a data set, introducing a change to a data set, and the data set breaks. So this is the daily effect, running a daily batch run. So the data set broke, the downstream data set broke as well. That's a problem, right? But at least this is a local effect. It only affected a single data set in a single day. And if the user in the next day, I don't know, the user is happy and understood the problem, introduces a fix, then the data set starts working again, and everyone is happy again. And you have no side effects. So we are not doing incremental for the user data sets. We're not doing things in incremental. We are paying the processing costs. Okay, we are like processing every day the whole data for that single data set. So we are reprocessing it again. But at least it's way easier to reason about the ETL. The next one is safety nets. Keep your DAG valid at all times. So that's kind of one old picture that we found that kind of represents how our DAG, dependence DAG, looks like, which kind of seems complex and hard to reason about. So it's really hard to, I don't know, to understand and know all the possible possibilities that something could go wrong. So, and one of the things that's really cool, and that's why in the beginning we said that Spark is really nice because you have a declarative and a lazy kind of representation of transformations, and which is the data frame. And as we know all the raw data sets, we know the schema of the raw data sets, and everything's based on those raw things. We can just, for example, generate an empty data frame, which is only the structure of the data frame, so it has, I don't know, DAVT columns, and we use that as input for the data sets, the user data sets. And we do that, and then the user data set's gonna get that DAVT and return a new data frame that applies some transformations and that so forth and so on. And that's really cool because at least you know that your DAG is valid. And you're not accessing a column that doesn't exist. You can do kind of a static validation only by using the Spark data frame, which is something that is really cool. So all our data set definition, they live in the same project. It's kind of a lot of Scala classes. And they're all, and as we declare the inputs and the definition, we can kind of create a DAG from that. And we can leverage this kind of testing. So that's interesting. But that covers only one case, right? The integrity test. Something that I think, as I said before, the DAG is really complex. And one of the things that we have in mind is that we cannot prevent all the issues that are going to happen. And things are going to go wrong. So what we want to do is mitigate those issues and reduce the blast radius. So we do that by adding integrity checks and doing anomaly detection. So integrity checks is basically a declarative way you can add to I don't know, your definition, your data set definition. This column shouldn't be null, this column should be positive. And if that check it doesn't pass, we just don't persist the data set and we don't apply the downstream dependencies to it. So we don't propagate this data set on, right? And in anomaly detection there's some really cool things that you can do with anomaly detection, but one thing really simple is that, for example, imagine that you declare your data set that it should have always increasing row count. And if it doesn't, you can also detect and this is really cool, for example, customers. It's really, at least in our case, customers should never decrease in row count. So, and we had we had some issues that kind of misplaced some joins and no one detected that failure and it failed. And we detected only later on in the pipeline because we still didn't have the anomaly detection and that would have caused this problem. And consumer-driven contracts where we have some downstream consumers of a data set and we want to just match if my schema in the analytical environment kind of matches the expectation of a consumer. So it's also something we use a lot. And the next one is think, iterate, deploy easily, which is, okay, it doesn't matter you have a super infrastructure, you have a lot of things, you use Spark, use this, it's just a black box, you just put your code there, but it really doesn't help the end user if he cannot iterate on the issue, he cannot iterate on the problem. So to solve that, one of the things that we use a lot is Databricks. So we have this REPL, which is really close to production, and that allows the end user, our business users, to test things, try new ideas, and interact with an environment that is really close to production, try out data sets. And then once they want to have that thing running every day, they just copy and paste the code, which is basically a definition of a data set transformation, and everything works out. And yeah, so when we think about iterate easily and deploy and do all those kind of things, I think you feel really empowered when you think that you are in control. So that's one of the things that we think a lot also is like the user wants to be in control of things. So I don't know, someone wants to create a new service and automatically we're gonna start extracting the transaction log. And then if the user declares the contract, that Scala version of the kind of contract between analytical, the production and analytical environments, the dataset is going to run every day, and then the user can add a new dataset. And from that, if he wants to create a dashboard on top of Looker, they can. And even if you want to use the serving layer, for example, like a serving layer is basically a way to put things back to production, like policies, machine learning models that you want to use in the production services, you can have that. And all of that automatically. So we are just like, meanwhile, we're just drinking beers and making sure the platform is working. But for the user, it's really important because the user knows that but they are in control of like the whole process and the whole workflow. So that's something that we really think when we are adding new features that they should have like the most control as possible. So with some results this is the number of data sets that we have, like the line, which is like 12K, and the bar is basically how many data sets a data engineer maintains. So it's really cool that we are seeing that we are adding a lot of new data sets, and we are also increasing the number of data sets per data engineer. So it's scaling. The idea is scaling. And as we add more data sets, we don't need to have as many data engineers. So the platform itself is scaling. Cool. So just some key takeaways is basically think about the roads you want to pave. You don't need to pave all the roads. You don't need to care for all the users. Just give a really nice solution. And people, as people join the company or people see, oh, this is a really good thing and I'm going to start using. The people that are more kind of resistant to the changes, they're going to just start using that because I think it's the natural way. Constraints are good. So this, when I mentioned like the Spark operation, it's a simple building block. It's constrained, but people found out a lot of ways of improving and doing different things. Something that is really key to our whole stack is like leveraging the transaction log, doing the change data capture. So we do that with Datomic, which is fairly simple, but you can do with Postgres, MySQL, or any database, which is basically like extracting all the data from a database and just extracting, and if you need this data later, you already have it. So the transaction log is really powerful. Instead of just, I don't know, scrapping the tables and doing selects, just getting the transaction log, and from the transaction log, creating your kind of contracts. Automate data ingestion to the extreme, have a dev environment closer to production to iterate easily, and validate your DAG in tests, integration tests, with anomaly detection and integrity checks. That's also super important. That gives confidence that the end user is not breaking the DAG or breaking the analytical pipeline. So with that, I'll close saying that we, as always, everyone is hiring. So we have a page, careers. We have several positions in Berlin, Mexico, Argentina, Brazil. If you're interested in some like summer weather, please reach out. Thank you, guys.
Thank you for the really nice talk, Rodrigo and Andrea. And now we have only 1 minute, so only one question allowed.
Yes, hello. Nice talk.
Thanks.
I just got a little bit confused in the end where you show the user data that went to a data warehouse and then you have Looker connected to that. But then you also have Databricks. And so you have, is it the same people looking in Looker and they're different types?
No, they're different. So you like more specialized, like data scientists, like more, I don't know, technical business analysts, they use Databricks, they love Databricks. And for, I don't know, people that are not that much technical, or we want to, for the management team having dashboards and so on, that's where we use Looker on top of BigQuery. But the data is all generated by the data pipeline, so it's the data sets are the same in both Databricks and in BigQuery, for example. It's just a different visualization tool, I would say, for different kinds of users.
Cool.
Just to add something, we also have a lot of Jupyter notebooks as well. So these are just an example of how people could use data, but depends on case from case, right? Like if in your company you have a lot of heavy users, maybe you should invest more in Databricks, maybe. So it depends on your case.
Okay, thank you everyone for coming. Thank you.
Thank you.